Hey, so we're just going to do a quick video about rationalizing denominators today. It's a topic that sort of a ton anytime you're dealing with square roots. Mostly because in order for a number or a value or a fraction to be perfectly simplified, its denominator has to be rational. That means that it can't have any square roots going on, right? If we have something like this, 3 over the square root of 2, that's not fully simplified because we have a square root or an irrational number, meaning it's not, an integer or a fraction, right? Because the square root of 2, right, it goes about, 1 point something on to infinity. It's not rational. And the rules for simplification say that the denominator has to be rational. So we have to rationalize this denominator for it to be fully simplified, right? Like if your teacher says, okay, make sure to simplify all your work on this test, and this is your answer, well, she might deduct points because you have it fully simplified. So how do you fully simplify or rationalize a denominator? It's simple. You get rid of any square, any roots whatsoever. I'm going to show you how to do it. So let's say we have 3 over the square root of 2. Let's say we have that original problem. We need to rationalize it, right? We want to make sure that the denominator has no square roots whatsoever, right? So how do we get rid of square roots? Well, I know if I have a square root and I multiply it by itself, like I have the square root of 3, I do the square root of 3 times the square root of 3. That's square root of 3 squared, which cancels out the square root, leaves me with just 3. So that's what we're going to do. We're going to multiply by the square root of 2 by itself. But in order to keep the fraction the same, right, because remember we don't want to change our answer value, we're going to multiply it by the square root of 2 over the square root of 2, which is actually just 1. So we're multiplying it by 1, so we won't change the fraction's value. It's very important because if you change the answer, well, then it's no longer the right answer or the right form or whatever. So we're going to multiply it by the square root of 2 over the square root of 2, which is still 1, so we're not changing anything. But it does allow us to cancel out that square root. So we're left with 3 times the square root of 2. And make more space here. So I'm going to have 3 times the square root of 2 over 2. And that is our final simplified form. Now you notice there's a square root of 2 in the numerator. It's fine if there are square roots or irrational numbers in the numerator, as long as there aren't any in the denominator. In this case, there aren't, so we have fully simplified this, and it's done. Let's do a more complicated example. Let's say we have something like 4 root 2 over, let's say, 2 root 3. And I'm asked to simplify, right? Now the first thing we can do is say, okay, well we can cancel out the 2's. Always a good thing to do. So that leaves us with 2 root 2 over root 3, which doesn't actually solve that problem. We need to get rid of this. So we're going to multiply by root 3. Of course, it's going to be root 3 over root 3 because we want to multiply by 1 so we don't change the value. Right? On the denominator, that cancels out and we're left with 3. The numerator, though, that's 2 root 2 times root 3. And remember, when we're multiplying square roots, we multiply these square roots together inside the square root. So we actually have 2 root 2 times 3, or I'm going to write down here, 2 root 6 over 3, right? Because when we're multiplying square roots together, we're going to multiply the values inside the square roots and put that all within one square root. So root 2 times root 3, that's just square root of 2 times 3, or 6. So the final simplified version is this. Once again, we have an irrational number in the numerator, but it's fine since our denominator is perfectly rational. Let's do another complicated one, just so we can get fully comfortable. Let's say we have something like 4 root, let's say 2 over 4, over 3 root 5. Now we can't cancel any of these constants, so we're going to have to keep them b. We're also going to want to when it cancels out that square root. So we're going to multiply by square root of 5 over square root of 5. Remember, got to make sure it's 1. Right? Now notice, we don't actually have to worry about this 3. Right? Because this 3, it's already rational. It's already good. We just need to get rid of the square root of 5. So what happens? Well, I'm going to focus on the numerator, on the denominator first. So that's 3 root 5 times root 5. That's going to cancel out the square roots and leave us with just 3 times 5, which is just 15. Now, what happens in the numerator? Well, that's 4 times root 2 times root 5. Right, so that's the same as 4 times square root of 2 times 5. Because remember, when we're multiplying two numbers with square roots, we're just going to multiply those two numbers within a single square root. Right? That's 4 root 10. So we're going to read this finally. 4 root 10 over 15. We can't simplify anything because the only thing we can pull out is a 4 or a 2 out of the numerator, and we can't pull a 4 or a 2 out of the denominator. So we're going to leave it like that as our final answer. We know, yes, indeed, the denominator is fully simplified, and that's that. And to end, we're going to do one last challenging problem, and it'll kind of test our abilities, because up until this point, we've been dealing with square roots, but you might also deal with different other types of roots, right? Like a cube root. Let's say we have something like 6 root 5 over 3 times the cube root of 6. Cube root of 6. How can we get rid of that? We can't just multiply it by the cube root of 6. That'll just get us cube root of 6 times the cube root of 6. It won't cancel out. But if we cube the cube root of 6, we will cancel out and just get 6. So what we have to do, we have to multiply it by cube root of 6 with the cube root of 6 times cube root of 6 the cube root of 6. And remember, we're doing this because we want to make sure we're multiplying by 1. We say, okay, we're multiplying it twice. That's really the same as the cube root of 6 squared, right? So you really want to rewrite this. You can write this as the cube root 6 root 5 over 3 root 6. Actually, we can cancel out the 3's while we're at it. So teachership is just 2 root 5. 6 over cube root of 6 squared over cube root of 6 squared. And then on the denominator, that cancels it out, so we're just left with 6. And we have 2 root 5 times the cube root of 6 squared. And unfortunately, we can't combine these two terms. We have a square root and a cube root, so we can't do anything. But we can actually factor out a 2 out of this entirely, and then 2 out of this entirely. So we can just have 3 over square root of 5 times a cube root of 6 squared, right? This is the most complicated form of rationalizing the denominators you would see, where you have to multiply it by the cube root of 6 squared. But just remember, for any root, figure out how many times do I have to multiply that root by itself to get rid of it. And then just take that number, take that value, multiply it on the numerator and the denominator, so you won't change the value of the original expression, and then do the simplification, do the distribution, do what you have to do in the numerator and the denominator, and make sure when you're done to say, hey, is there anything new I can factor out? And in this problem's case, there was, and we did that. And that leaves us with a nice final answer, and we've successfully simplified that problem. So whenever you rationalize denominators, just make sure, clear the denominator out of any roots, anything irrational, and make sure that you do the same thing in the numerator as you're doing in the denominator. Other than that, that's it. I hope you found this helpful, and I hope you have a great day.